Hello everyone, and welcome to another problem solving video. This time we're going to take on a much harder problem from Leetcode.com. This problem is called valid number, and what we have to do is write code to determine whether or not a number, which will serve as our input, is a decimal or an integer. On the surface, this doesn't sound like something that's too hard to do, but there's a lot of different requirements in here that make this problem a little more difficult to solve. I really encourage you guys to go into the description and click on the link to the full description of the problem to really get an understanding of some of the challenges that we have for this particular problem. For instance, just to give you guys a few examples, an integer 2, 100, or 1,000 are normal integers that we're accustomed to seeing every day. But for the sake of this problem, something like 0089 serves to be a valid integer. The decimals, on the other hand, are even more difficult because some of the decimals may actually have an E in it. So as we see in this example here, you may have something like 10.5E3. We also have to take into consideration the lowercase and uppercase of E. These are both valid decimals for the sake of this problem. And we also have to take into consideration the plus or the minus sign. So, how do we go about solving this problem? Well, one solution, or the simplest solution in my mind, is to come up with a series of regular expressions that would match the input. We go through all of those regular expressions and we test them against the input. And if the input comes back, then we know we have a valid number. So what will our regular expressions be? Let's say that we have one regular expression called an int pattern. This one will test against integers the way we've known them for all of our lives. So -9 plus 10 or just 0. We'll have another pattern called no digits after a dot pattern. So no digits after dot pattern. So for the sake of this example, something like 9 point with nothing after it is a valid decimal. Something like 10 point is a valid decimal. So there are no digits after the dot. Then we can have another expression where we have digits before and after the dot. So these are your typical decimals. So we'll say 10.4, -10.80, and in this example, something like -10.6E5. And finally, we have one more pattern that we're going to create that's going to match up against our input. Let's call that one digits before the dot pattern. So an example of this would be something like 0.7, 0.7E10, 0.7E-5. So now that we have all of our regular expressions, what we're going to do here is we're just going to write a little bit of pseudocode. Now that we have all 4 of our regular expressions that we're going to use to determine if a number is valid or not, let's go ahead and write some pseudocode just to get an idea of what our actual code would look like. So assuming that we have all of our regular expressions in a collections, maybe an array or some type of structure, what we can do is iterate over that structure and test each regex against the input. So let's go ahead and start that. So for each regex r, what we want to do is we want to test that regular expression against the input. And if that's true, meaning that we tested our input against the regex and we have a match, what we want to do is return true. Now, if we encounter the case where we test all of our regular expressions against the input and none of them come back as a match, then we want to return false, which is an indication that we do not have a valid number. So let's go ahead to the code view and code all of this out, run it, and see how it works. Okay, so what we're looking at here is the JavaScript implementation of the pseudocode that we saw previously. So let's just go ahead and outline what we have here. So what we see is our isNumber function, which is going to determine whether or not a number is valid. The S is the argument that we're going to receive. And before we go into the code here, let's take a look at what else we have. You see all of our regular expressions that we talked about in our pseudocode, one for testing integers, one for testing numbers that decimals that do not have any numbers after the decimal point. The third regular expression that we're seeing here tests for numbers decimals that have numbers before and after the decimal point. It also takes into consideration the E that we have with some of our numbers that appear after the decimal point. And finally, what we have are numbers that appear before the decimal point with nothing in front of the decimal point. And we also see here that we can have signs that appear and then the decimal point followed by numbers. So again, this is a very difficult problem to solve when you take into consideration all of the different requirements. But this is the simplest technique that I could think of when it comes to solving this problem. And as we saw in some of the previous videos, we just have a test function that goes through all of our inputs. Now, a word about these inputs. A lot of these valid numbers, some of them come directly from the problem, and some of them come as a result of testing that I've done, where Leetcode sort of kicked my code back and said that, hey, this doesn't work. What you're going to see when we go to the Leetcode view is a clean view. That's because I created an account simply for doing these problems and making these videos. I'm not perfect by any means, so don't be fooled by a clean Leetcode sheet. Some of these invalid values, as you can see, same from the description, and some invalid values that Leetcode sort of detected that my code didn't account for. I thought that keeping those inputs would be good to illustrate during our run of the implementation of our algorithm. So as we saw before, we're just going to go over each one of these. We're just going to iterate over each one of these valid numbers and invalid numbers, and we're just going to log the output. The output in this case is just going to be the number followed by what we get back, true or false value from our isNumber function. So, and finally, we call our test. So let's go back to our isNumber function for a second. As you can see, it looks very similar, almost identical to the pseudocode. Almost identical, except that we're taking the regexes from the array of regexes that we sort of created a global value of. So let's go ahead and run this right in IntelliJ and see what happens. All of our valid numbers should come back saying valid, and all our invalid numbers should come back saying invalid. So let's go ahead and run this in IntelliJ and see what happens. Okay, let's scroll up a bit and start at the top. You see all the valid numbers to 0089. We talked about that on the whiteboard view, and some of the other rules that are in place according to the description. And it looks like our function is working pretty fine. It's working pretty well. And you see the invalid numbers, the obvious invalid numbers, and the not so obvious invalid numbers we can see as we scroll down. So I think this is ready for testing in Leetcode. So we're going to go and move over to the Leetcode view and let's test it out. Okay, everyone. So now we have our code put together that we've seen previously in IntelliJ, and now we're going to go ahead and run this into Leetcode and see what we have. Like I've said in previous videos, sometimes we'll run into situations where I've already run some of these test cases for the very basic, the very given and easy test cases that Leetcode provides. I've never submitted this code before, so it may pass the very first time that we run it. Again, don't be fooled by that. I've run into the same difficulties that many other developers have, and I found inputs that didn't work. So I created a new account for this, so that's why it has a clean slate in terms of these submissions. But let's go ahead and submit it, and let's see what happens. And Leetcode's doing its thing, and there we go. So now we have our results in JavaScript. There's our JavaScript code. You notice it's slightly different. We took out the test cases and we had the function be assigned to the is variable, the is number variable. Sorry about that. And let's take a look at some of the results here. You can see that our running time is at 70%. In my opinion, I think that's pretty acceptable. You might feel differently, but then again, we're grassroots programmers here, so we're not looking for perfection. We look to improve in our craft as best as we can, but we do realize that sometimes we are going to provide solutions that has limitations. But if we take a look at the memory, it only beat 10, maybe even 11 if you want to round that up, percent of the people of other submissions, the other programmers, in terms of memory. And something like this would never really be acceptable. We would have to find ways to improve performance here. Again, it's not a very easy problem to solve. It's one of the hard problems on Leetcode. So take a look at the solution I provided here. And if you have a better design or better solution, or could maybe even make suggestions, I'd like to hear about it in the comments section. And please feel free to subscribe to this channel, and I will continue to make videos. And if you subscribe, you'll get notifications about when new videos are out there. And this will conclude this video. I hope you enjoyed our whiteboard view, our code view, and looking at this on Leetcode. There will also be another video with the Java-based implementation throughout Leetcode and in IntelliJ as well, so I encourage you to watch that video if you're interested. But again, guys, that concludes this video, and I will see you on the next video.